All right, welcome everybody to our Birds of Feather session on defining criticality, which open source projects truly matter. I'm Jonathan Reimer. I'm heading our internal data platform and our insights product here at the Linux Foundation. And with me is Sam, who is a data scientist at the Linux Foundation and recently joined us from Harvard University. Before we start, one question. Who has participated in our Birds of Feather session before? Okay, a few people. So before we get started, I want to quickly use the chance to introduce a format. This is not a classical talk or breakout session. This is meant to be an open discussion. So we're going to start by introducing our perspective, but then we really want to make the floor or give the floor for you to give your perspective and your opinion on that topic. So yeah, please keep that in mind. And I would like to start a bit with the motivation of why we are doing this session here. And the background is that I think we all know that there's a lot of open source projects. I looked it up this morning. I think it's 420 million repositories on GitHub alone. But the reality is that only a few thousand of those really matter because they're used by companies and developers in production around the world. And usually if you think about open source projects and, for example, security aspects of it, you will notice that your resources are probably limited. So measuring and defining criticality is a way to help you prioritize on which projects you want to focus. So we, as Linux Foundation, ran into this problem as part of LFX Insights when we started onboarding projects to LFX Insights that are not part of the foundation. We had the question, which projects do we onboard and in which order? Because you might find lists of projects online and you can go by that, but the question is there a data-driven approach to, let's say, really onboard all critical open source projects that there are? So that's a bit how we got to this problem. And how we do it today is we basically took the OpenSSF Criticality Score, which is a number between 0 and 1, 1 being the least critical, 0 being the least critical, 1 being the most critical. You can calculate this number pretty much for any GitHub repository, and it includes factors like project age, contributor count, commit rhythm, release cadence, and dependency reach. So we did that, and it's great, but we also noticed that there is some room for improvement, because the first thing that we noticed is OpenSSF Criticality Score mainly works for or mainly focuses on GitHub hosted projects. The second issue that we notice is that the inner ranking does not always seem to be very plausible. So if you calculate it for all projects on GitHub, you will just have projects in the top 100 that clearly don't belong there. And the third one is kind of related to it. You will have, for example, docs or the code of project websites and so on with a very high ranking because maybe a lot of people contributed to it or for other reasons. So if you look at all these factors here, they can obviously be manipulated or gamed in different ways. So that's kind of where we were at, let's say 4 to 6 weeks ago. And Sam especially worked on the criticality score and did some research on it. And I think he would like to briefly introduce what we came up with. And then I'm super curious to hear all your thoughts on the topic.
Yeah, so my work takes the OpenSSF Criticality Score as a base. It's a great starting point for thinking about how to combine a bunch of important community signals into a single numerical composite. However crazy of an exercise that is, it's useful for a lot of purposes. OpenSSF uses it for the purposes of identifying important projects for security improvements. Ours is slightly different, and in your use case, it might be even a little more different. Maybe it's projects that are critical to your organization specifically, or are skewed more towards widespread social impact or other factors. So we're going to use the OpenSSF Criticality Score as a base, and we'll start by looking at what's the top 10,000 most starred repositories. Have to use stars as some signal to base it off of. And then we filter out docs, mirrors, forks, template repositories as best we can using just the flags from the API. We also combine this list with a list from the OpenSSF themselves, which was a manually curated list of about 150 truly critical projects that were deemed by experts to be truly critical. Some of these exist on GitHub and would have been found from our search. Importantly, some of them would not have been found. They're hosted elsewhere. But the common thread amongst all these projects is that they're tracked in a version control tool, and it's Git-based in our case. One thing that we do once we have this list of 10,000 is we have to start measuring signals and coming up with a different score. So one thing, our main approach is that we kind of simplify the parameterization of the scoring function. We select a subset of signals that we think are less biased towards just pure activity-based or like commenting activity. It's a really durable signal of community growth and widespread usage and take-up of the project. And we slightly modify the function used for scoring. In a nutshell, we're going to take about 6 signals. We look at the contributor rank, the number of distinct committers, and we assign that a very high weight, about a 40% weight. We look at the diversity, organizational diversity in the commit log by looking at like distinct emails within the commit log. Also are looking at slot count. I know it's not a great measure of importance of a project, but you would think that a legacy code base that has evolved over time and is not easily replaceable ought to receive higher weight in this ranking. We also check things like the age of the project, when it was last updated, and how often commits are being added to the project. And you might notice a common thread amongst these signals is that they can all be derived from a commit log. The problem with scaling beyond a GitHub-oriented search is that you have to make sure that signals are consistently measured across different project sources and different like VCS hosts, all these things. So right now we're just looking at things that can be identified from the commit log, but we would love to expand from there if there's ways that we can consistently do this across projects. Because if a signal is inconsistently measured, it's going to completely bias the ranking and might not give you good information. So we're going to restrict to a set that we're reasonably confident can be consistently measured across all these projects. One thing that I think the OpenSSF does really well is that they incorporate dependency information. They go beyond simple package manifests and SBOMs. They look at the commit log and they count occurrences of another project's name in my commit log, and you might infer that I have formed a dependency with that project. So it's not perfect, but it's definitely a more scalable way than just thinking about packaging ecosystems and recorded dependency relationships. So for example, Kubernetes, you could argue, depends on the Linux kernel, but you would not find that in a packaging manifest for a Kubernetes project. So when we're thinking about dependency information, that's some direction we'd like to go next, but isn't in our current iteration. And you might be able to think of a recursive approach to this as well, where if I support many other highly scoring repositories, my score ought to be higher as well. And another suggestion that we haven't implemented yet is that this should be part of like a feedback loop. If our rankings are off or you think that there should be modifications to the rankings, we ought to update them and incorporate that feedback. So just running this over maybe the top 10,000 or so projects, our objective is basically to drive a wedge or the separation between the orange and blue points. And so when we're comparing to the OpenSSF method as a baseline, we see that these truly critical projects, which are the expertly selected projects that are decided to be the most critical projects in the world, they are rising to the top, whereas there's a little bit more overlap in the OpenSSF default methodology. So our objective was purely just to drive a wedge between these two distributions. we have a full link. It's linked in the PDF and attached. And if maybe at the end we can show you some of the maybe like the top 20 to get a sense of how these rankings with this calibrated score match up to the OpenSSF methodology for maybe like the top 20 projects. In our mind, it looks a little more reasonable, and it'd be interesting to hear what you think. We did try a machine learning-based method where we trained a classifier to predict a score based on the expert chosen list. The issue is that even with rebalancing and using a bunch of tricks, the machine learning classifier just performed very poorly. So we were a little more comfortable with deriving a score-based classifier from scratch. So just to recap some of our suggestions for future iterations, this was just the first pass. It's by no means meant to be definitive. It might not even fit your use case if you endeavored to try to rank repositories, but we would suggest improved filtering. There's clearly some forks. If I have a fork of the kernel that's basically identical to the kernel, your repository, if it's not filtered out, it's not tagged as like a fork on GitHub, it might appear of similar rank to the kernel itself. So maybe one way to solve that would be use tags or look at the description or the README and sort of classify these projects as, oh, this is clearly docs, this is clearly an SDK, or this is clearly a fork of the true canonical project. And I'd love to move beyond a set of signals in the VCS logs in some scalable way. I'd love to hear your suggestions on this front. And implementing some type of user feedback loop, I think, is very important. I think that's the original spirit of the OpenSSF approach, was that it wasn't meant to be the end-all. It was meant to be a guiding tool and iterated upon and used just to identify potentially critical projects. I'd love to incorporate dependency information. I would love to hear your thoughts on scaling that. And then, of course, you can have your own parameter sets. We chose parameter sets that off of feel, basically. What parameters gave us a ranking in the top 20, top 100 that showed projects that felt critical to us, but your use case might be different, so there's no need to have one single parameter set. So.
Yeah, I think with that we basically would open the room for discussions. These are just for orientation. I mean, maybe you already have thoughts just based on what we just talked about. So I'll check with the mic and then we can get started.
While he's looking for the mic, can you go back to the beginning? I wanted to understand before your slides, his slides, in terms of what problems you were trying to solve with criticality score.
It's kind of what we talked about on the slide before, right? I mean, for us, it's about which projects do we onboard to LFX Insights and in which order. Because we have limited resources and we cannot onboard 400 million repositories, just talking about GitHub, right? So the question is, which projects do we want to focus on? I think that also opens the question, what's even critical, right? Because you can see critical in a security context, you could just see any project that has a lot of usage as critical. That's a bit the question, but you want to...
I'm going to dive right in, yeah.
Have a microphone. Yeah.
Break the ice. So Michael Windsor, I work on the Alpha Omega project. So we fund security improvements in open source projects. And there are a couple of interesting lessons that we've learned along the way. So one of the problems we have is which projects should we fund? There's way too much to fund everything, and so which ones need the most attention? And we've found that the criticality score, which by the way was derived from a score that Rob Pike defined a long time ago, and it represented sort of a popularity plus some other things. Here's a fundamental thought. Every single dependency you pull into your project has total access to your build environment and total access to your runtime environment. So when someone talks to me about criticality based on lines of code or what it does, I am uninterested, because in my context, if I'm looking at my project and all my dependencies, they all have equal access to my project. And so now I look like, where are the weaknesses coming from? Not how important it is in the broader ecosystem. So your goals, Alpha Omega's goals of finding however things are very different from an individual project that's sitting there evaluating the risk in their world. And I think that's a really, and the danger of the criticality score from OpenSSF's scorecard is that it lets people sort of just say, look, there's a number. I'll go look at the number and I'll use that. And that number is global, and it is based on a very limited view and inadequate to the needs of your particular context. And so I would much rather we did not aggregate these numbers. I'd rather we'd have all these different dimensions of information and then a bunch of tools that help you evaluate in your context against that metadata. So one of the things that we're looking at, and I think you're familiar with ecosystems, ecosystem.ms, right? Andrew's not here today, he'll be here tomorrow. We're very interested in projects, for instance, that don't have lots of contributors, and in fact don't have a lot of churn. Because if a project has constant inflow and ingress and egress of contributors, it's healthy and can handle new people. If it's got no churn whatsoever, it's stable, but it's also static, it's stuck. And if somebody wanted to help out, they probably don't have the process to help out. And so they represent interesting little nodes of risk. And then we're looking also for queries that might help us find projects that have never had to deal with a vulnerability. Because they have vulnerable code, but they've never had a CVE reported to them, have never had, or the author has never done so. And so those are dimensions from our perspective of like, where is there in the next XZUtil situation waiting to happen? Or where is there a bunch of unexplored problems that are sitting there, boring code that all of a sudden become the next attack surface? Anyway, that's my perspective. I thought I'd get ice going. Anybody else?
I think there was one very important word for me in what you just said. Like it's context dependent. Like its criticality is not an absolute thing. It's different for everybody. But I would rather view it from like the industry's point of view. It's not from other open source projects' point of view, but like how those projects are used in products or in other.
Right, their dependence. Who depends on them?
Yes, who depends on them? And I don't know how do you want to use the dependency here, but I think the important is that what depends on that project. So it should be something similar to like this Google page ranking algorithm to find the most critical projects. And I didn't know about this OpenSSF Criticality Score, but it looks more like I don't know, marketing score, or which project gets more stars or more contributors. There are lots of critical projects which do not have lots of contributors and lots of activity, but still, like they are stable projects, very old dinosaur projects, but they are still there, and they are very, very important.
This whole criticality thing makes me remember, or reminds me of an XKCD, where we have the modern software stack of anything you look at, and then there's this little tiny project that holds up everything, and if that falls over, the whole stack falls over. And that would make, in my mind, criticality. So we have this small project that is maintained by one very enduring, very patient person, and if that one goes away, or I don't know, has to be replaced, then everything falls.
Yeah, that meme is a bit overused these days, so I didn't also
But it's true.
But it's very true.
You're not allowed to do a talk on supply chain security without including that slide. It's now required.
No, it's very true. I mean, if I understand this sentiment correctly, you're almost saying it doesn't even matter if a project is only used by one other project, right? I mean, if something is a dependency for the kernel, for example, it almost doesn't matter if no other project relies on it, because if that project has a security issue, the kernel potentially has.
I agree. I'm going to make an observation more meta. This room is small enough that we can probably make do without the microphone, if that will improve the flow of communication.
Yeah, sure.
Otherwise, we'll be shuffling back and forth.
Yeah.
I'd like you to stand up. If you want to talk, stand up. Is it recorded?
For me, but I'm missing
Yeah.
the ease to read.
Sorry. No, she was talking and I'm quiet. Go ahead. You're up.
I can? Okay, fine. I'm missing how easy it is to replace a software component by another one. Can be that it's important, and it can be unreplaceable, or it can be important, but it's fairly easy to replace it by another project. And I'm missing this.
Yeah, I mean, even in a lot of packaging manifests, you just have a binary, does it depend on, or maybe you have a runtime versus dev dependency, something like that. If there was a more granular or continuous measure of the extent of my dependence on how many lines of code would I need to write to completely replace the dependency, you could start with the lines of code in the dependency as a upper bound and maybe a lower bound of 1 or something like that. But I think a broader issue, I totally agree with the sentiment that the dependencies are important. One bigger issue is that they're inconsistently observed across ecosystems. And if we could do a better job, I think SBOMs are a way to move towards better cross dependencies between ecosystems. But right now, you're kind of patching together, we leverage ecosystems as well. They parse a bunch of different packaging manifests, GitHub Actions, all sorts of CI usage. If you could take the union of that, that would be great. But I think you would even be missing more nuanced relationships. Like this project wouldn't exist without the kernel sort of thing. So if everything kind of circles back to one central important repository, that should be reflected in the perfect software dependency graph. And then I totally agree with like adding some recursive component, page rank, network centrality measures could basically reweight the score to favor these central dependencies.
I think you could overfit on trying to get a great story on dependencies, especially when you're doing a global optimization.
Totally.
There. I think that when you're back in a specific context, so the gentleman from Nokia is looking at project X and it has a specific set of dependencies, right? It knows exactly, or it should know exactly what ones it has, and it can worry about those projects specifically. In a global context, where you're trying to figure out which ones should we even bother paying attention to, you're going to pick a whole bunch. If you're off a few here and there, like maybe there'll be some false negatives of things you really should have found. They'll probably bubble up in some other context as well. So.
I got one here. You talked about collecting those data. Would it be one idea to have a tool collect them and not present it in score? You could present score, but you can choose to just show the different data.
So
That's being done. That's currently being done by the OpenSSF as a tool that runs about roughly every once a month.
Yeah, but you could probably.
it's available as a database.
Yeah.
Yeah, but I'm thinking also you could add scoring points so you can manipulate what you are showing from different projects. So that you were talking about, so you can collate the information and you can choose from your perspective.
Right. I think that's something I've wanted from Scorecard for a while, with some more modularity and extensibility. I don't think it's going to happen for complex organizational reasons, but I think that certainly having conversations with ecosystems folks about an extensibility model that would allow us to run arbitrary modules that essentially analyze and produce some dimension of score and then becomes available in the metadata around that project.
Yeah.
So I think, being able to bring your own perspective, and in fact, I'd love to see literally an ecosystem of ecosystems of different tools that have their different analyses of like how to assess something, looking at the dependency weight, looking at the dependence weight, right? How many things does this pull in? How many things does this get pulled in by? The depth of it in that tree, like the gentleman here was asking about how easy it is to replace. Well, I can tell you that it's somewhat linear to the depth in the tree, because if you're up here and you're saying, we should stop using that, which is used by something down 17th out of the tree, you have no power to make that change, right? You have to go off and influence lots of people who use it to cause them to make that change. It's hard.
Yeah, I do have a question going back to the funding choice that you made based on the criticality score. Is that this OpenSSF score might indicate healthy projects, and maybe not projects that need funding, and maybe it might fit over healthy projects over projects that need funding because of that. So I'm a little bit worried about that.
Yeah, so the criticality score itself doesn't really say if a project is healthy or not. It rather tries to give an estimate if it's critical or not, and then I think defining if that project needs support or not, for that you would look at other metrics. Yeah.
And I can tell you from our perspective, we don't use the criticality score or even the scorecard scores as a primary or even secondary indicator for where we will fund. Our fund is more honestly anecdotal in terms of how we do it. You go to the process, you fill out a form, and then the next process is you talk to me. So it doesn't scale very well, but it's how we're able to make decisions in, like we don't feel it, first of all, we're not big enough to go off and just throw money at every project saying, you need $100, you need $100, you need a car. So we're not at that point of funding anywhere near. And if we were, we would not use a score that could easily be gamified because it would, right? Please modify your score to get money is not the game we want. But, if I may, sorry. Everybody, so how many here represent corporations that are pulling in open source as part of their dependency graph and risk? It's okay, you can admit it, we're all doing it, right? How many of you have any engineering resources pointed towards maintaining any part of your upstream supply? A little bit. Good. I saw shaking hands, right? You have three choices. Remember I said, like, everything that's coming into your supply chain has total access to your build environment and total access to your production environment. Tell that to your security people, right? Tell that to your compliance people. And so you have three choices. You're either going to fork, you're going to fix, or you're going to forget about it. Those are the three F's. And you're either doing one, and if you're not doing one of those, you've implicitly done the fork, because you're now maintaining a downstream copy of it that you haven't updated in a while because it broke the build last time. And so those are your choices. And organizations that don't start working their way upstream to take care of that are going to be, essentially what's the right term? The tail being wagged by the dog, literally, as opposed to the other way around. And that information you don't need a global score like these gentlemen are talking about. You can just go look at your stuff and figure it out.
What would be interesting for those kind of situations would be a similarity score, where you can say, like, I know this project does the same thing or similar-ish thing as this project, and then look at them, what's the dependencies on that one, what's the dependencies on that one, what's the CVEs on that one, what's the CVEs on that one, and what do you want to maintain, and what's the lower risk for us as a company, and then pick one of the other.
If it was as simple as that data is not available, and the biggest cost is the switching cost. So that last choice to forget about it, it's really expensive because now you have to find some other way of doing it. And it's not that I don't want to have multiple variants of these things here, but I mean the complexity of these, the interface you have to any module, any piece of code it's astounding. So yeah.
But it's an alternative to forking it on your own and then putting it in your own.
Maintaining your own downstream fork is a different kind of expense. There are literally the best possible solution anybody has is to build a relationship upstream with a dependency that you've observed as being critical, and to say, and so there was an example of this. Again, I don't mean to dominate the conversation. I warned you I had a lot to say. We worked with the Airflow project, big project. They have, at the time we started working with them, 719 transitive dependencies. That's just on the back end. We don't talk about the front end. It's a class. And instead of doing an audit of the code, they did an audit of the health of those projects. And they tried to prioritize which ones they were going to, fix, fork, or forget. The result was really interesting. They didn't need to make, this is to my point, they didn't even get all the way through the list. They did about 200, 300, and immediately 16 to 20 things bubbled up right away as needs our attention now. Doesn't matter about if we find more, these need our attention right now. And in some cases, they were able to drop it, stop using something because it was a lightweight test dependency, or why the hell is this still in here, or it's a thing in an external module they can take care of. In one case, they kind of ended up forking it. So there was a project that was called a Chronitor, and the maintainer was looking at the CRA and felt like they were going to become a manufacturer in the eyes of the law, and they didn't want that stress, and they said, I'm done. And they actually worked with that maintainer and managed to negotiate a move into a foundation for the source code, and there's now a community of people maintaining it. It's effectively a fork, right? But in the other cases, we had some automatic scanning going on, finding bugs in the code. Classic thing, like Daniel was talking about earlier, the sort of AI bots were producing things, and people are now inured to that. Someone from Airflow would just show up on the ticket and say, hello, I'm from Airflow, I care about this ticket. Would you mind fixing this vulnerability? It's real and we care. And the people were overwhelmingly happy. They were like, oh my God, you know I exist? You're here to have, right? So literally you don't have to do anything. You just have to show up and say, I care about you as a project. here's a bug, would you mind fixing it? And just the presence of a human being. And so that's sort of simple, like in the United States, there's a bunch of highways that are not properly kept clean, so they get companies to pay for some meaningless advertising and they adopt a highway, right? Well, adopting an open source project where you show up on that project and say, we're a user of yours, we're using it for free, but we just wanted to say hello. And then when there's a moment of crisis and you need their help, they already know what you want. Because when the crisis happens otherwise, they're too busy dealing with all the lawyers who are asking them to prove that they're not committing open source crimes and don't want to, anybody else coming in is untrustworthy. So the social component of that work, I think, leads to a lot of the criticality that we care about. The ability of the maintainers to handle situations, the vulnerability history, those are the signals I really find lead to what matters.
So we could kind of add another F to your fix forgets fund in the name of either throw money at it, throw manpower at it, or people at it.
Right. So funding is much harder than that.
Yeah.
So imagine you are, back to my point about the projects that haven't had any churn, right? You can't buy more nights and weekends. These people are already working as hard as they can, so if you give them money, you might get them a new laptop, but you're not going to get them the prioritization or the stress reduction they need.
I'm not necessarily talking about money, it's also
Engineering resources.
engineering resources, or appreciation.
So again, if a project has never onboarded somebody, adding an engineer is a monumental step forward. That's why that signal is really becoming top of priority for me, because they are the projects where there is no obvious path to helping them. They are working as fast as hard as they can, and we don't know what to do. And so the criticality, and this is the difference I think between criticality of how important this is and risk in terms of how much risk there is. But I agree, showing up and saying hello, it's awesome. Fund them with
Appreciation,
yeah.
I think you also want to say something.
Yeah, so I have this kind of meta thought or comment on this. So suppose this becomes a success. This becomes the Forbes billionaire list of open source projects. And at some point it becomes kind of a vanity metric. So people implicitly or explicitly want to make the list, and just sort of start to gamify the system. I was thinking that, so this is kind of what the Google folks have been at forever, like people gaming their system, and what they've done is try to make the game a positive for the end user. So you game the system by actually producing good content. At least that was one of the ideas. So I was thinking in this case, maybe folding in some of that thinking at this point, maybe that onboarding people as a signal, maybe that's a way to get that kind of vanity metric and gamify it in a positive sense. And maybe the source lines of code is a negative one because people would just kind of AI slop into their projects, and but so just seeing this and
Makes totally sense. But I would guess that by onboarding new people, you would probably increase your contributor rank, right, or your organization rank. So those with 60% already kind of play a big role in that. But I think it's also important the point that you had, that I think there's two terminologies that are being mixed up. The one being most critical, as in this is most important projects, and the other one which are at the highest risk at this point in time, which is totally different questions to ask, and you also need different kind of data points to answer them.
I mean, I would ask then, if we're thinking about criticality, right, its weight in, like, the number of things that depend upon it seems like the high order bit. Like, I don't care if it has one contributor named Daniel or 3,000 people working on it called Kubernetes. It's how many, in many ways, almost how many contributors downstream depend upon that. Like, you could do some weird adding up the contributors for the downstream side and getting this sort of weighted sense of like how much energy is sitting on top of this thing and how much pain there'll be around it. I don't know. It's
Maybe I back at this KCD comic.
We try to. I mean, for this kind of memo, we try to do it with this definition. We said an open source project is critical if it is either directly relied on by many users or indirectly through other widely used products that depend on it. So that would mean even if one package is just used by one other package out there, but that package is widely
Right.
popular, this would make
Doesn't
all
matter, yeah.
dependencies popular as well. So that's kind of how we try to define it for our purposes.
But we don't have that dependency signal in the current
Yeah.
set of parameters. But I think that's the important thing is gather a bunch of signals, you know, maybe suggest, hey, these are parameterizations that might deliver this result. You can play around with different signals and different ways to combine this information into a composite that works for you. And I think that's maybe the most honest and transparent thing we could do, is just,
I would love it if
Yeah.
your tooling was an open source project, like built on top of,
Totally.
I think to your point and others, like the more we can make the process of developing your own sort of analysis tooling on top of basic metadata,
Yeah.
the more, I think, progress, innovation, insight will emerge more broadly.
Yeah.
So I would happily coordinate around that to
Yeah.
sort of see some sort of a garden, like let 1,000 flowers bloom here and see
Sure.
what we can find, right?
Yeah. I mean, I think we're gonna have the discussion on that maybe on Wednesday,
Wednesday
right?
for sure, yeah.
But I think this is maybe about giving access, for example, to some of the metrics that we have as Linux Foundation as part of Insights
Yep.
that you can use to, for
Right.
different kind of purposes.
Yeah, and this gets back to like your goal, and again, I'm sort of pushing back, like, gotta get some crappy dependency stuff in there right now.
Yeah.
Start with that.
That's
get-
fair.
Provide totally useful signal right away, and then rely on the feedback mechanism to tell you that you completely missed it, something like that.
Yeah.
And like, okay, why, figure out blah, blah, blah. But like, there are low-hanging fruit, I think, well worth your attention on.
Totally.
things like that.
That's a good point.
Yeah, I think ecosystems probably gives you that
Yeah.
data, even if it might not be perfect yet.
Yeah,
It's something that
definitely.
you need to add. Because the metrics that you have, I'm sure there's a lot of correlation,
Yeah,
right?
sure.
But if you have dependencies, you have causation also. I think it sends even a stronger signal to people that are wanting to use or consider this.
Sure, yeah, or like exogenous variation outside of my package. You know, if I support a ton of really highly scoring packages, I should have a much higher score for having supported them, directly or indirectly.
Thank you. What?
If you would be able to know who or if you consider instead of from analyzing the grain, the code, analyzing from the business feature, so who that affects and which type of industry or specific situation that affects, considering a social technical environment.
I think that fits with our broader notion of criticality, and I would love to move towards that. If we can, scalability always becomes a concern. Maybe you score, maybe there's like a tiered system where you cast a wide net to try to at least get the top 10,000, and then you take smaller and smaller cuts, being like, okay, I could probably manually code 1,000 repositories on which industries, who's using them, what's the nature of the software. One other one would be, you know, how is it being actually used? Is it, you know, encrypting someone's homework, or is it encrypting nuclear launch codes, or, you know, like medical research or something like that? Might be different, right?
One observation,
Well, I was just, on the weights here, you mentioned they were just kind of, sort of picked out of a reasonable, you know, setup. So, just coming in here from a session on machine learning, which is essentially about finding weights at a large
Yeah.
setup of weights. I was just curious if there was any kind of thought into some kind of, you know, way to structure a way to kind of find those weights, comparing it to maybe the ones, you know, the expert pick
Totally.
list, or maybe even a simulation-based thing where, you know, you would like to see your.
We tried exactly that, and it just, the ranks were just all over the place. It was even noisier than trying to come up with your own weights. But I'm not opposed to giving it another try. Like maybe if we expand the training list, maybe if it's not the top 150 projects relative to, you know, 10,000, 500,000 projects on the, you know, technically not critical. Maybe if we kind of expand that, or there's, you know, there are layers to this. We have scores in the top 10,000 that we're pretty confident in. Maybe we retrain on that and then refine the weights from like a default that was arbitrarily chosen. Yeah.
Usually with the machine learning approach, you go with labeled data, so you would have to have the labeled data first.
Yeah, exactly.
Rather than
So we rely on about 150.
and that list, I know how it was built,
Yeah, yeah,
It's not the list you're looking
it's
for.
tough, yeah.
You got a better one?
You got, yeah,
No, there isn't a better one, right? It's not intrinsically bad.
yeah.
But
It's just a hard thing to do.
It's got a ton of false negatives, let's put it that way.
Sure.
Right?
Yeah.
And to generally question, one of the interesting things we did with one of the industry associations in the United States, I'm not gonna say which one it was, rhymes with ranking. They looked at what their top graph of dependencies was. They would never, because the banks don't want to say, I'm using this, right? But they're quite comfortable sitting behind an industry association saying, banks in general use this. And so we were looking for like, what is the most commonly used software in banking? Newsflash, it was the same crap that everybody else is using. So to do, that sort of most important critical, depending upon a definition of the term, enumeration of things, it turns out everybody depends upon a lot of the same stuff. When you go looking into the software that is specifically tagged as this is medical software, for instance, like that, the dependency graph will be a very different thing, and you need to walk that graph to find what they use. But the commonality is depressingly clear. People use, there are no homework-specific encryption algorithms, right? People just use encryption, good or bad, they pick one and use it, and so on and so on. But I think that going back to the very beginning of the conversation, if you start with a particular context and apply this tooling in that context, you will find interesting information that is actionable in your space, whether it's an industry association or a specific project or whatever. And that gets back to like, why are you looking at this data? What are you trying to achieve? Because there is no one score that tells you everything you need to know. This is one thing you take away from today. There is no one score that tells your boss what is the most valuable thing you have on your project.
I think those are good closing remarks. We actually have to end the discussion here because Sam has another session in 7 minutes.
Okay.
So thank you all for coming and discussing. I think this was very interesting from our perspective. There's for sure still some work to be done on this. If you want to keep involved or engage more with this, and we put all of the work on GitHub. I will update the deck in the conference website as well, so you get access to that. So you can take a look at it, and also obviously open issues or open discussions there if you have some afterthoughts. Thank you.
Thank you for hosting.
Thank you.